Find the APR, the annual percentage rate or stated rate, in each of the following cases. In the first case, we're told we earn an effective annual rate or EAR of 8.6%, and we have semi-annual compounding. We can solve for the APR by using a mathematical formula, which is the APR equals M, which is the compounding periods, multiplied by the quantity 1 plus the EAR, which in this case is our 8.6%, to the, in this case, 1 over 2 power minus 1. Again, 1 over 2 because we have semi-annual compounding. In solving this, we end up with 2 times the semi-annual interest rate of 0.0421, or an APR of 8.42%. We can also solve this using our financial calculator. If we use our financial calculator, since we have semi-annual compounding, we'll put 2 for the number of compounding periods. If we begin with an initial investment of $1, and again we'll put 0 for the payment since our payment field is only for use for annuities, and we want to know how much our $1 investment today will grow to in 1 year if we have an 8.6% EAR with semi-annual compounding. We will enter 1.086 for the future value. This is because with an 8.6% EAR, or effective return, our $1 initial investment, the present value, will grow to a 1.086 future value. Finally, we can solve then for the interest rate, and we solve for a semi-annual interest rate of 4.21%. Then to convert this semi-annual interest rate into the final APR, we simply multiply it by 2 for the number of compounding periods. In case number 2, we're told that we have a 19.8% EAR with monthly compounding. Again, using our mathematical formula, we would take the quantity 1 plus 0.198, the EAR, to the 1/12th power because of monthly compounding. Subtract 1 from that, and then multiply that monthly rate of 0.0152 times 12 compounding periods, and we would get an APR of 18.20%. Once again, using our financial calculator, with monthly compounding, we would enter 12 for the number of periods. We enter $1 for our initial investment, 0 for the payment, and a 19.8% EAR, or effective annual rate, means our $1 investment will grow to 1.198 at the end of 1 year. We then solve for the monthly interest rate and get 1.52%, and we can multiply this by 12 to get the APR of 18.20%. In case number 4, we're told we have an effective annual interest rate of 16.5% with an infinite number of compounding periods, or continuous compounding. To solve this mathematically, we need to use our log function. Our APR will simply equal the natural log of 1 plus the 0.1650 EAR, and we get an APR of 15.27%. We can also get a close approximation to this using our financial calculator. With continuous compounding, we have a very large number of periods, so let's pick a big number, say 1,000 for the number of periods. Again, we'll enter $1 as our initial investment, 0 for the payment, and for a 16.5% EAR, our future value of our investment will grow to 1.165. Then we can solve for our interest rate. The interest rate that corresponds to 1,000 compounding periods is 0.01527%. Finally, to convert this to our APR, we would multiply this by the number of compounding periods, or 1,000, and again we get the 15.27%. Once again, our financial calculator using 1,000 for the number of compounding periods gives us a relatively close approximation to continuous compounding.